Welcome back to Math 103. This is video number 5 for voting theory. At the end last time, you were asked to find the winner of the following election under instant runoff voting, and then write down the overall ranking of the candidates under the extended instant runoff voting method. Okay, so how do we approach this? We look at the first choice votes and ask, is there a majority candidate? No, there is not a majority candidate. C has a plurality of first choice votes, no one has a majority. So we're not going to declare the winner in the first round. We have to eliminate the candidate with fewest first choice votes. And that is A, right? A has only 3 first choice votes, so A is the one who is eliminated. So in the first round, A is eliminated, so we know that in the ranking, A is going to be in last place. Right. So now, in the second round, what happens? Well, B moves up a slot to second choice on these 10 ballots. C moves up into second choice on these 8 ballots. B moves up into first place, and C moves up into second on these remaining 3. So what does this mean? It means that B now has a majority of the first choice votes after we've recomputed, after we've retallied. Okay, so just to be entirely clear, and it's not a bad thing to write this out when you apply the method, although this gets cumbersome for a large number of candidates and a large number of rounds. In this rewriting of the preference table in round 2, we see that B now has 11 out of 21 first choice votes. C has only 10, so it follows that B wins. Great. Finally, we work out the ranking, which is easy to do because we've already done all the real work. So the ranking is in reverse order of elimination. That means that in third place will be A, second place C, and first place B. A was eliminated first, C was eliminated next, and B was the last one standing. Good news! The instant runoff voting method never violates the majority criterion. That is good news indeed. Now, why is it true that it can never produce such a violation? It's useful to look at an example to reason it out. You'll notice that in this example, C is a majority candidate. We looked at this example earlier. And what happens when you apply the instant runoff voting method? Well, in round 1, you ask, just looking at the first choice votes, is there already a majority candidate? If so, then by the rules of the method, that candidate is declared the winner right away in round 1. That's just how instant runoff voting works. Now let's be careful about how the term majority candidate is actually used. The term majority candidate in an election refers to the preference table as originally given before any eliminations have taken place. So in this other election that we've looked at in previous examples, where C does have a plurality but not a majority of first choice votes, it's true that when you apply the instant runoff voting, A is eliminated, and then you've got B and C moving up accordingly, and it's true that in round 2, B has a majority of the first choice votes in the round 2 sense. Yes, B is the winner, but B is not what we call a majority candidate for the election as originally given. That's a little bit of a subtle point. This election does not have a majority candidate. Having a majority candidate is something that's true about a preference table before you apply any voting methods to it. Our third voting method is the Borda count method. This is named after a French mathematician of the 18th century who worked in many areas and proposed this voting method, among many other accomplishments. So this method is based on a point system so that every entry on every ballot counts for something. We could criticize instant runoff voting for making only incomplete use of the information in each ballot. It made more use of the information on each ballot than just the plurality method, but Borda wants to use every single entry and count it for something. So here's the idea. Every last choice vote is going to be worth 1 point. Every second to last choice vote a candidate receives is worth 2 points, etc. And if n, don't be scared by the use of a letter in this course, it's not so scary. This just means however many candidates there are, we're going to call that n. So if there are n candidates, then each first choice vote a candidate receives is worth n points. Okay, if there are 5 candidates, then a first choice vote is worth 5 points. A second choice is worth 4 points, all the way down to last place, which is worth 1 point. Last place is always worth 1 point. Now, the candidate with the highest total number of points is the winner under the Borda count method. There is a lot to be said for this method. It has many advocates. It's not used very much in political elections, but it's used in a number of other contexts. Now, as with any voting method, there's an extended version by which we rank candidates using the same work we've already done to find the winner. So if the winner is whoever had the most points, then whoever had the second most points gets to be in second place overall. Whoever had the third most Borda count points gets to be in third place overall. Now, where is it used in real life? Well, one important example is in ranking college football and basketball teams. It's used in other important aspects of our civilization as well. So here's an example. Find the winner of the following election under the Borda count method. Right? I urge you to pause the video here for a moment and work this out. Now, A has a certain number of first choice votes, a certain number of second choice votes, and a certain number of third choice votes. We will fill those in. So A has a total of 3 first choice votes, a total of 18 second choice votes, right? This is a total of 18 second choice votes right here, and then 0 third choice votes. Okay. B has 8 first choice votes, 3 second choice votes, 10 third choice votes, and finally C has 10 first choice votes, no second choice votes, and 11 third choice votes. So C is a very polarizing candidate. Everyone either loves or hates C. So we tally these up. So A has 3 times 3 is 9, plus 36 is 45 points. B has 24, plus 6 is 30, plus another 10 is 40 points. And finally, C has 30 points worth of first choice votes, plus another 11 points from last choice votes. That gives you 41 points total. And the winner is A. This is the same A who lost under the plurality method, in fact, was in last place, was also in last place under the instant runoff voting method, and is now the winner under the Borda count method. And there's a lot to be said for that. If you look at it, A is not despised by anyone, it seems. A is a candidate who is most highly favored by very few voters, but at least tolerable, it seems, to the overwhelming number. A convenient way to check your work when you use the Borda count method is to add up the points that all the candidates have received. This should equal the total number of points on each ballot multiplied by the number of ballots. So each ballot had 3 points, 2 points, and 1 point to give out among candidates, right? each individual voter can be thought of as allocating 6 points, 3 of them going to the first choice, 2 of them going to the second choice, and 1 going to the third choice candidate. Great, so that's a total of 6 points per preference ballot. Great, so now we know that there are 21 voters, each one casting 6 points per ballot, for a total of 126 points. Great, now we check against the point totals we found earlier for the 3 candidates. A had 45 points, B had 40 points, C had 41 points. That's a total of 126 points. Excellent. These two numbers agree with one another. It is conceivable that we miraculously made 2 errors that cancels one another out, but it is overwhelmingly likely because the total number of points given out by all the voters and the totals we've computed for each of the 3 candidates, because those agree, that suggests strongly that we have not made any arithmetic errors. Note that this one election, with the preference table we've been looking at, has had 3 different winners so far, under the 3 different voting methods considered thus far. So remember plurality method? The plurality method made C the winner. The instant runoff voting method made B the winner, and now Borda count makes A the winner. This really underscores our observation that it is of enormous consequence which voting method you pick. You have to make a very deliberate choice before the fact of which voting method you're going to use, since the entire election outcome could depend on that choice. Before going on to the next video, find the winner of the following election under the Borda count method, and rank the candidates under the extended Borda count method. Once you've done that, do you notice anything disturbing about the election result?